Alrighty, friends, let's figure this out. Let's zoom in a little bit. So, Mrs. Q, sketch a graph whose a function whose domain is that, whose range is that. Alright, I'm just gonna be lazy. -4, -6, 1, 2, 3, 4, 5, 6. 3, 4, 1, 2, 3, 1, 2, 3, 4. 5, 5. You don't have to do it this way. This is the way my brain wants to do it. 5, 1, 2, 3, 4, 5. And 9, that's 5, 6, 7, 8, 9, -2. Alright, so that fit. I just did each point. So -4, -6. You don't have to do it that way. You could do -4, -2. It doesn't matter. At what point can we add to make this function no longer a function? So you have lots of flexibility here. I could add the point 3, 0. That would be an example. But you could add a number of points. I mean, an infinite number of points. Sketch the graph of a relation whose domain is -infinity to infinity and whose range is 3 to infinity. Okay, so I gotta go 3 to infinity. So that goes left and right, keeps going, and then starts at 3, goes up. Doesn't have to be the only answer you gave, but that's a possibility. Must this relation be a function? I mean, there's nothing that says that I couldn't do something like this. Oh, wait, no, can I not do that? No, because I got to go that way and that way. Let's see, can I come up with something? Yeah, I could do something like this. And then I could also do this. Something like that would fit the spot. So it does not have to be a function. That's a little crazy. I don't know that y'all would come up with something kind of exactly like that. But it is possible. Given the graph of f of x below, sketch that on the same graph. Alright, for this one, let's make it bigger. So that's multiply y by -2, then subtract 3. And then this piece says move left 1. So if I take out the 5, 5, multiply by -2, that's -10. And then if I go down 3, that's -13. So that's not terribly helpful. Can I get any of these on the graph? 3 times -2 is -6, minus 3 is -9. Okay, so I'm going to fix this graph for you because this is an obnoxious graph. Oh, I changed my mind. I was just looking at it, and I changed my mind. Here's what I'm going to do. I'm going to make this a positive. So make that a positive 2, because then I can get her done. So if I do 5 times -2, I'm doing the y value. 5 times 2 is 10, minus 3 is 7, and then if I go left 1. So that point goes there. So that's 4, 7. And then if I do 3 times 2, which is 6, minus 3, that actually puts it right back there, but we go left 1. So we're right there. Let me get rid of that dot. Hey, that dot. And then if I connect your dots, that is your new line. If you wanted to do another point, I'll show you another point because that one was a little hard to see. That original point is -2, 4. If I do 4 times 2, that's 8. Minus 3 is 5. And then if I go left, so right there. That'll work better, and I fixed that on your review for you, so that will actually fit. Given that graph. Okay, so this is saying, this one says, we'll do the easy one first. That one says up to. And now we want this -2 thing. So we got -2x. That one's a little bit trickier. What we have to do there, it looks like we're multiplying x by -2, but what we're really doing is dividing our x values by -2. So if our x, so divide x by -2. So if I take the x value is -3, divide by -2, that's 1.5. And if I move up 2 for the y, that's 1.5, 0. And then if I do the same thing with, say, this point, if I do the x value times divide by -2, that does nothing, and then up 2 is here. I'm going to pick this point here also. That's -2, -3. If I divide that by -2, I get 1. And then if I go up 3, I get -1. So 1, -1. So your curve's going to look like this. It gets a little bit skinnier. Things happen 2 times faster is what's going on there. As a note, often those ones inside the parenthesis, those transformations are a little bit scary. And so we do those on the review and not necessarily on the quiz. Just a fun fact. All right, I made 2 edits to this before I gave it to you. This is x minus 1, and this is f of 2. So that says g of f of 2, so I need to find f of 2 first. 5 over 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. 5 over 5 is 1. So that's just 1 in there, so I got to find g of 1. So that's the square root of 1 minus 1, which is 0. F of g of x squared plus 1. So g of x squared plus 1 is the square root of x squared plus 1 minus 1, which is just the square root of x squared. F of the square root of x squared is 5 over 2 times the square root of x squared plus 1. I didn't rewrite the square root of x squared because a lot of y'all are going to want to write that as just x. It's technically not just x, it's the absolute value of x, but the process is accurate, what we just did. Use the table below to answer the questions. Okay, so this looks scary, but let's see. G of 2 is 2. So that's g of h of f of 2. F of 2 is also 2. G of h of 2. H of 2 is 3. If you're confused here, I'll help. So the first thing I did was g of 2. Second thing I did was f of 2. Third thing I did was h of 2. And now I just have to figure out what g of 3 is. So g of 3 is 3. And next one says 2f of g of h of 0. So h of 0 is 1 plus 3. And that's going to be the same as 2f of g of 1 is 2 plus 3. And then 2 times f of 2 is 2 plus 3. So 4 plus 3 is 7. Just follow the process and it's not too scary. Sketch the inverse of the function in the graph. Okay, if I'm sketching, I kind of want to put in the line y equals x, because that will help me figure things out. So I have the point 0, 1, that becomes the point 1, so these points just flip-flop. And then I have the point 2, negative 1. 2, negative 1 becomes negative 1, 2. And I have the point 1, 2, 3, 4, 3, so that becomes 3, 4. So if it goes that way, it's got to kind of go that way. Oops, wrong thing. Got to kind of go that way. And then if it goes that way, maybe that way. And then that way. So it looks kind of like that. So that should be symmetrical. I think I messed up the blue. But it's the right idea. I'm not going to worry about it. If you have that, then you're okay. Find the inverse of the given function. So first thing I want to do is write it as y, because that makes more sense in my brain. That will make it not be in function notation. Then I got to give the old flippy flop with the x's and the y's. Cube both sides to get rid of that cube root. Multiply both sides by 2. And And then I'm going to subtract 3. And finally, I'm going to multiply by -1. And I did it. And I bet if you graph those, put those into Desmos, you'd see that they are inverses.